For the fourth question, we are going into system of equations, and here we need to solve this system of linear equations. Alright, linear equations, either using the elimination method or the substitution method. Right, so to choose which kind of method, let us understand when should we use the elimination method and when should we use the substitution method. Right, so for elimination method is to solve equations that have three unknowns and they are linear. For substitution, it would be solving the non-linear equations. Right, so if we see the equations here, each of them have three unknowns, and those three unknowns are separated by plus and minus, so all of these values here are all linear, right? Which means that we are going to use the elimination method. Okay, so for non-linear equations, it's actually equations that has, okay, let's say for the previous question, right, like 1 over y, 1 over xy, or xy, and so on. Right, so you see these things are actually non-linear. Okay, so if you see in this system of linear equations here, there is no non-linear stuff. Right, so we are not going to use the substitution method. Okay, so we are going to use the elimination method to solve this question. Right, and it will be the fastest way to do so. So before we use the elimination method, we need to be clear on this method's aim. Right, so elimination method's aim is to eliminate the unknowns one by one until we have left with one unknown and we find the answer of that unknown. Right, so let me repeat again. The aim of the elimination method is to eliminate the unknowns one by one until we left with one unknown and we find the answer of that unknown. Alright, so for the elimination method, there are 5 steps, so let's go through them one by one. Right, so for the first step, among x, y, and z, we are going to choose our first unknown to eliminate. Right, so here, let me recommend you all to choose y. Okay, later you'll see why. Right, so let me put a star here, so just in case I forget. Right, so for the first step, we are going to choose the first unknown, which is y, to eliminate. Okay, so let's go to the second step. Second step is to choose 2 equations among the 3 equations here, and we need to make sure the value of the unknown that we have chosen is the same. Okay, so means, let's say if I choose these 2 equations, I need to make sure that the value of y is the same. Right, so now you can see that the first equation's y is 3, but the second equation's y is 1. Right, so to make sure it is the same, we are going to multiply 3 for the second equation here. Right, multiply 3 for the second equation here. So once we multiply, you can see that the value of y have the same value, which is 3. Okay, so now once the value is the same, then we can go to the third step. We can either add or minus to eliminate the unknown that we have selected, which is y. So means that we can either add or minus these 2 values and to make sure the y is eliminated. Right, so let us use add first and let's see what is the result. Okay, so negative 3y, I add with negative 3y. So positive and negative, it would be negative, right? So negative 3y minus 3y is actually negative 6y. If we add them up together, this value of y does not disappear. Okay, so this means we cannot add. So what we need to do is the other method, which is to minus. Okay, and let's see what happens. So if we minus negative, negative, positive, right? So negative 3y plus 3y, then in this case, the value of y will disappear. and it will become 0. So this means we are going to minus these two equations to eliminate the value of y. Right? So minus these two equations means that for the values of x here, I'm going to minus them. So 2 minus 9, which is negative 7x, negative 3y, negative 3y. So just now we have shown that it will become 0. So this thing will disappear, means y is eliminated already. And for the z value, same thing as well, z minus 6z, which is negative 5z, and the value here 16 minus 57, which would be negative 41. Alright, so we have our first equation without y already, but here there is still two unknowns. Right? There is still two unknowns, and if we want to solve two unknowns, we need to have two equations. Okay, so since we only have one equation here, we need to repeat step 2 and step 3 to find another equation. Okay, so for this time, to choose the two equations, I will be choosing the first equation and the third equation. Right? So why I didn't choose the second one is because if you look at the value of y, it's the same. Right? If we ignore the signs, right, negative and the positive here, if we ignore it, the value of y is actually the same, which is 3. So if that's the case, then we don't need to multiply anything. Right? We don't need to multiply anything. We can save our work. Right? So we can just take these two equations out, and then we are going to do step 3 to either add or minus to eliminate the y. Okay, so let us try out add first. Right? So negative 3y, we add the positive 3y. So positive is positive, right? So negative 3y plus 3y, then this will be 0. Okay, which means we need to add these two equations together to eliminate the y. Right? So we are going to add up all of the values here. So this would be the result. And you see that the value of y disappears. Okay, so now we have two equations which has x and z inside. So we can find out the value of x and z. But before we go to the next step, I would like to explain why I chose unknown y in step 1 just now. Alright, so let me explain it this way, why I didn't choose unknown x and unknown z. Right, so let's start off with unknown x first. So x is because if you look at the values of x, right, there's no value 1. But for y, there is 1. So why is it so important? Why we need to have the value 1? Right, reason is because of step 2. Because step 2, we need to choose two equations and we need to make sure they have the similar values. So for example, y just now, we multiplied one value for one equation here. But if you imagine, we are using the same equations and we are eliminating x, you can see that if you want to make sure both of the values are similar, we need to cross multiply their values. So meaning for the first x here, we are going to multiply 3, and the second x here, we need to multiply 2, right? Because 2 times 3 is 6, 3 times 2 is 6, and both of them have similar values. But if you see here, we multiply two values for two equations. So there will be a lot of working and it will increase your risk to make careless mistakes. Right? So this is why the value of 1 is very important, because we can save our work and we just multiply one value for one equation. Right? So this is why I didn't choose x, but how about z? Z actually has 1 here, right? The value here is 1, but why we don't choose z? Right, reason is because of the second pairing. So if you see our second pairing is the first equation and the third equation. These two values of y are the same. But if you look at here, all the values here are different. So if you imagine, if we use the same pair of equations and we need to make sure these two values are the same, so meaning the first equation here, we need to multiply a value, right? But if we choose y, we don't need to multiply anything. We can just take it and then just add them, right? So why we didn't choose z is because we can also save time, save our workings, and reduce the risk of making careless mistakes, right? So this is why we choose y. But of course, if let's say in the exam you cannot decide x, y or z, it's okay, just choose one of them and then just solve, right? But please make sure that your working is correct lah, right? Please make sure there is no careless mistakes, and you will also obtain the same amount of marks when you solve the equations here. So coming back here, so now we have these two equations, and these two equations have only x and z inside. Y is already eliminated, right? Y is already eliminated. So now we need to further eliminate the unknowns until we have left with one unknown. Okay, so this brings us to the fourth step. We need to repeat step 2 and step 3 to eliminate the next unknown, right? So for the next unknown, let me recommend y'all to choose z, right? Reason is because the value of z here for both of the equations is smaller compared to x, right? The smaller the number, the easier we can solve the question. Alright, so for step 2 here is to choose two equations and we to ensure the value of z is the same. Okay, so these two equations and we to ensure the value of z is the same. So to do so, we can cross multiply the values. So means that for the first equation here, I'm going to multiply with the value of the second unknown, right? So the entire equation here will multiply with 4. And for the second equation here, we are going to multiply the value of z from the first equation, right, which is 5. Okay, so once you multiply 4 for the first equation, multiply 5 for the second equation, this will be the result. Okay, and you can see that the value of z is the same. So now for step 3, we need to see either we add or minus to eliminate y. So this time, let us not try out add or minus to figure out which is suitable. Let us look at what have we done here and let's see is there a pattern, and we apply the pattern here. Okay, so if you see this one, the y values, they have the same sign. Same sign, then we use minus. But if it's different sign, then we add them, then the y will disappear or eliminated. So we can use this pattern. If same sign, we are going to minus. If different sign, we are going to add. So now coming back here, the signs are different. So means we are going to add them up together. Alright, so for the value of x here, negative 28 plus 30, so here would be 2x. These values, when we add up, it will be eliminated. So z would disappear. And the values here, negative 164 plus 170, so here is 6. So if we move 2 to the other side, then we will get x equals to 3. Right, so we have achieved the aim of the elimination method, which is to eliminate the unknowns one by one until we've left with one unknown, which is x, and we find the answer of that unknown, right, which is 3. So now let's go to the fifth step. Let us use back the equations that we have to find back the value of y and z. Okay, so for finding out the value of z, I'm going to substitute x equals to 3 inside this equation. Alright, so we can find out that the value of z is 4. And let us use the value of x and z. We substitute inside one of the equations here. Okay, so let's say I use this one. So when we substitute and we rearrange the equation here and there, we can find out the value of y is negative 2. Right, so here let us write a final conclusion of our answers. So here x equals to 3, y equals to negative 2, z equals to 4.